thank you for your kind introduction. So I am Akira Maezawa at Yamaha Corporation, and this is a joint work with my colleague, Kazuhiko Yamamoto. So basically what we've built in our project is a machine musician that could interact with human musician in a music ensemble. So like this is going to be like useful in a setting where, imagine you're a musician, you want to form up a band for your next gig, and you aren't able to find like your cellist because the cellist is too busy or you don't have any friends. You will have a machine that will be able to supplement the musician. So in this talk, in this paper, I'm going to focus on one particular example that we did last year. This is a concert for a string quintet. So we have 4 strings and 1 piano. On the strings, we have the members of the Sharon Ensemble of the Berlinfeld, so they're like the best musicians right now, right? And on the piano, we had recuperated performance of Sviatoslav Richter, who is like the godly late piano legend of the 20th century. Like he truly represents the piano playing, in my opinion. So we had this concert, and the piano part has been played back using our machine musicianship system. So I'll show you like a 1-minute video summary of the concert. So the Sharon Ensemble starts playing, and Mr. Richter joins the band. And he plays Russian melody. But it's not only the melody. Sometimes the ensemble becomes more intricate. Or sometimes Mr. Richter would support the human musician. Yes, actually. Over here, Mr. Richter becomes the accompaniment supporting the human musicians. The important thing is that unlike orchestra, this is a very tight-knit, intimate ensemble. No, they have these varying roles. They play as one musical unit and end the piece like that. So that's our concert. Actually, yeah. So in order to achieve this kind of capability, we need 3 things. First of all, we have to get the musicality of Mr. Richter come across. So in order to do recuperated performance, usually a piano player has been used a lot. Basically, so player piano is this acoustic piano with a bunch of bells and whistles so that you can drive the keyboards and pedals from external electronic input. So you can use that to recuperate some historical performance, and that really kicks whoops. Yeah, so that really is awesome. But now if you use that in a music ensemble, it doesn't really quite work because music ensemble is basically interactive. So check this out. Okay. What was that? Okay, maybe we'll get better next time. Not. So basically, no. Playing back is enough. We need an element of interaction. So as a starting point of our study, we started with the automatic accompaniment system, which has been studied extensively. So in this system, we have a piece of music to play. It contains the part of what the human should be playing and what the machine should play in response. And in these systems, when human plays something, it uses the audio cues to find and uses technique called score following to find out where in the music score the human is playing. You can use that to keep track of where the machine should play in response. And there you go, bam, that's automatic accompaniment. We tried this in our initial design. We brought it to Berlin and tried this out, and it didn't quite work, which kind of motivates our work. So it didn't work because it didn't address all of the issues of music ensemble. So music ensemble is actually not only audio, but it's audio and visual interaction. So if you imagine, you need visual information to get the piece going. So if you're a violinist and I'm a violinist, so if you want to start a piece, you would provide this anticipatory motion and start. So you won't go bam. No, that's bad. You have to go bam. Otherwise, that kind of visual information is critical to start a piece or to recover from some of the critical pieces. But once you have the piece going, then you can use auditory cues. You can basically play with each other blindfolded, right? So, but these 2 modalities have never quite been integrated, so we incorporate that. So that's one contribution. Also, music ensemble is all about switching musical roles. I mean, you have seen in the video, musicians Richter doesn't only play the melody, he accompanies and anything in between. So what is role? Role is in musical ensemble leader versus follower, but these aren't quite these aren't really mutually exclusive. It's kind of like a fine gradient between leaderness and followerness. So when you're a leader in the ensemble, you kind of have an autonomy. You tend to pull others towards your musicality, whereas if you're a follower, you tend to give away your musicality towards the others. So how do we determine this? Well, there are two factors. One of them is musical common sense. So if you read the music score, some things are too obvious. Like if you have these kind of nice rhythm, then they tend to be the lead. If you have melodic line, you tend to be the lead. But it's not really clear cut. So there's lots of discussion that goes on during rehearsals to determine who's going to be the leader. So in our machine ensemble, we found that the Sherman ensemble, they said, okay, over here we like the Russian nuance, so let the machine sing here. Or on other parts, they say, okay, the humans are playing, so let us lead here. Okay? So that's oral discussion based, and accompaniment system should be able to address these spontaneously in order to be anywhere useful. Now, if in existing studies, if they address these kind of duality between leading and following at all, they tend to use machine learning techniques, which is really good because you can automatically acquire these tendencies. But the con is that you need training data to learn these, which means it's not spontaneous. If the Berlin Philharmonic stops playing at a particular passage and say, hey, dude, I want the past 16 measures to be more led by the machine, you have to prepare the training data. So we instead used a different tack. So we start off with like reasonable value of coordination. We model it in such a way that it's easily adjustable during the actual rehearsal. And whenever these musicians stops playing to make these requests, we just tune the parameters. So this is spontaneous. You can do kind of training. We actually never quite end up doing training. But the only, I guess, the downside is that you need human musicians that know their stuff. You need musicians who know where to lead, where to follow, which isn't a problem in our case because, like, dude, we are dealing with like the best musicians in the world right now. Yeah, so basically those are the two issues. Also, if you want to use this in a concert, it shouldn't fail, and this is very difficult. So if you go back to interactive music systems, there are like two gradients. Like automatic accompaniment system, you have fully autonomous system. So in these, you have a bunch of bells and whistles to show that if things go wrong, things will suck least bad. On the other hand, if you want, there are fully manual system like where you tap the beats, human taps the beats and sequences the music. But that's kind of tiresome to use in a long concert. So we take the middle ground. We have partially autonomous system most of the time. If things starts getting shady, human operator would intervene. So that's kind of like the issues we addressed in our system. So let's talk about how the system was implemented. So our system, first of all, creates not only the piano player output, but visual, because remember, visual is useful for anticipation. So we generate this anticipatory motion over here, like here. You see this bobbing of the head before the piano starts playing, right? So this provides anticipation for the piano part. And we found that this is really effective, especially when the piano has lead and the human musician has to follow the machine. Okay, so that's the of the sequencing. So how do we drive that? We have a bunch of recognition gadgetries. So on stage, what we do is we place a bunch of cameras and microphones to pick up the sounds and like the visual info, because humans also provide these anticipatory motion. So with video info, what we do is we detect for this, this kind of motion. So first, a bit of upward motion, followed by downward motion, followed by getting back. So we recognize that as a cue. Once we have the cue and the audio signal, we have kind of like a revamped version of score following to take both into consideration to keep the track of position in the music score. Now, once we have the position in the music score, we want to find out where the machine should be playing. And remember, this is the balance between leading and following. So we consider this stochastic differential equation that governs the dynamics of what the machine should be playing. So basically, it's kind of like a spring mass system with time-varying spring stiffness. So this gamma guy is a stiffness that says, hey, the current playing wants to revert to human playing. The other dude, beta, says, no, I want to play back with the original tempo, the original recuperated performances. So these govern the leader and followers relationship. And so we initialize these to reasonable values using symbolic analyses. And we adjust these parameters during the rehearsals. And it's worked to be quite efficient. Okay, and also to ensure a failure-free concert, we have the guy. the operator. So the operator's job is to monitor the confidence of the score follower. So basically, this is the confidence that the score follower is following a particular place in the piece of music. So if the confidence gets too low, operator comes to rescue and intervenes in various ways. So now let's look at how this was used in the preparation for the concert. So this is kind of interesting. So in the system operation, most of the rehearsal involved adjusting the gamma and the beta, the spring constant guides. And that was important in improving the accuracy. Okay. Also, the musicians agreed on who gives cue at where. Also, in terms of system intervention, we found that the system fails consistently at consistent places. Therefore, interestingly, what happened was that the operator ended up notating on his music score where the system would go wrong, so where to start the intervention, how to intervene, and when to end the intervention. So the failure modes were quite predictable. During the concert, we have 15 minutes of playing. Of those, we had 20 seconds of highly predictable, again, manual intervention. Okay, so let's see what the listener had to say about the concert. The reviews were quite favorable. There was no negative issues about the timing, and they thought that the nuance of Mr. Richter also came across, which means that the ensemble was both, the leader and follower relationship were properly set, so that you can have the musicality of Mr. Richter come through while having a nice, coherent ensemble. On the negative side, some people thought that the system was not being so spontaneous to changes of human playing. Others actually, on the other hand, thought that humans ended up playing on the safe side. So I guess this suggests that current ensemble system is still not as flexible as a human musician. So a human musician kind of gets pulled towards this inflexible mode of playing. Okay. Now, so what did the musicians have to say? So during the rehearsal, once we adjust the gamma and the spring constant guys, they said, okay, things are 1,000 times better. They have nothing to say. And interestingly, after this, they started discussing higher musical issues like matching the nuance of human musicians to the Russian taste of Mr. Richter. So I guess this shows that our system at least provides a bottom line for allowing musicians in the human music ensemble to start making music at a higher level than simply matching the timing. The musicians also said that the system lacks humor in that the touch, which is the dynamics or the relative elongation of the notes and stuff like that, are consistent every time. This is kind of like our specification in a way because we want to maintain the nuance of Richter, but I guess this kind of leads to our future work. In order to address this problem, we should match more musical elements. And there are some studies that are towards this, but I think there are still many roads to go. Also, and I think simply tracking isn't now enough. We have to be able to understand the underlying intent in order to respond in a more reasonable manner. Yeah, so I think that concludes my presentation, and I really had to do this. So, yeah, thank you for listening, and I conclude my talk. Thank you.
Hello, Jocelyn Spence from Mixed Reality Lab at Nottingham. This is not my area of specialty, but just gave me a thought. When you were talking about people responding to your work, they were actually physically there in the space, so they saw everything as well?
Yes, so they saw the shadow movements, they saw the keyboard movements as well.
It just put me in mind of when it was hard to get women hired onto symphony orchestras, and then they started blind auditions, and all of a sudden, the timid performers were strong. If you had people just listening, perhaps you would get less of this sense of lacking humor. Just a thought. Yeah,
actually, I think that's an interesting point. There's probably some effect of having no performer on the stage, and there's definitely the audience seeing the machine aspect as well. So we have to look into that. I think that's a nice, interesting point. Thank you.
Any other questions? Okay, I'll ask a question. So how applicable do you think your system is to maybe a different piece of music or different types of music?
Okay, so our system, we have used this in various genres of music, and especially for classical repertoire. And the current limitation is actually the level of musicality of the musicians. So you need quite a high musicality. You need strong musical understanding to be able to coordinate the ensemble to a reasonable level. We have tried with different personas, target users about this, and right now this particular system is geared towards the top-notch players.
Well, thank you so much. Let's thank the speaker.
Thank you. Can I unplug this?
All right, so while we're just doing a changeover, so something that I found really interesting about this next coming paper is how it used music for something that could be applicable to all sorts of other areas, which I think is something that happens a lot traditionally with music and HCI. So for example, in this case, it was using the H metaphor as a tool. So we have Adrian Hazard to present this paper, and he's going to tell us how he did that. Thank you.
Thank you very much for the introduction. Yes, my name's Adrian Hazard. I'm from the University of Nottingham, and I'm going to be talking about playing fast and loose with music recognition. Recognition systems such as speech, gesture, and in our case, music, have enabled for new modalities within HCI. But in turn, these have also raised new challenges, specifically how people understand the complex behavior and how to control such systems, particularly as they may be unpredictable. We explore this space via a new